All right. So later on, when we get to this particular chapter, okay, we are going to learn more about the strings and instances where um, we have to definitely use the single quotation mark or the double quotation. So we'll get there as and when it becomes necessary. All right. Now let's look at the other data types. The next one we are going to discuss is what we have over here as integers, okay? And the definition of integers, as you are going to learn now, is nothing different from what you already know from algebra. So an integer is a positive or negative whole number. So if I'm to say age, and this time around the declaration is not going to be in any double quotation mark or single quotation mark. When I put it out raw like this, okay, then this one is going to be, since it is a positive whole number, this is going to be, how do you call it, an integer. If I'm saying temp, okay, or maybe temperature, and I say negative 90, because this is a negative whole number, both age and temperature or temp are all going to be regarded as integers. So once again, let me just do a printing of the variable age as we currently have it over here. And then also, let me also try checking out the data type of age. So I'm wrapping everything up in the type class over here. So when I run this, yes, the variable age is going to be printed out and we're expecting to see 12. And then the data type, when we run it, we're also expecting to see int or integer. So when I run it this way, we clearly see that, okay, it is 12 and then it is int. However, if I put this in some quotation mark, then this one changes the whole dynamics, okay? Look at how it looks like over here. It looks like 12, okay? When I run it, now that it is a string, because I've put it in some double quotation mark, when I run it, it is still looking like the 12 we saw previously. However, the data type has drastically changed. So we have to take note of that. It is not necessarily how it looks like, but then how it is declared. That will determine the particular data type it is going to assume. All right. Now let's look out for the temperature or the temp variable we have also declared over here. And we are saying that this is negative 90. Remember, it is either a whole number, okay, positive or negative. So over here, when I run this number is indeed negative, but because it is whole, we are being told that this is an integer or an int. And these are numbers we are going to deal with, especially when we are working with the neural networks and stuff like that. The next one is going to be of more interest because this one is going to be fractional value. So not all numbers are whole numbers. We can have fractional or decimal values. So within the context of machine learning, we heard Prof mention a lot about the weight, okay? And the weight can be, usually they are randomly generated. We are going to come to that point where we can do some simulation of random generation of numbers. But this time around, let's assume maybe it is something like a 4.5, okay, something like this, 4.5. Now, the 4.5 you see over here is a fraction, okay? It is a fraction. So with this fraction, if I'm to do a printing of weight, okay, and also to do a printing of the data type of weight, we are definitely going to see that, yes, it is 4.5, but because this is a fractional value, it is going to be seen as a float. It is going to be seen as a float. I'm going to come back to this briefly to lay emphasis on the float, which will make a lot of sense later. So these are floats, these are fractional values. So typical examples are maybe your GPA, okay? And maybe GPA is 3.99, which I believe is a very good GPA. So these are all examples of floats we can think about. The next one over here is very important because of the fact that we are engineers and we're working with some of these things along the line, some may pop up. And it is a complex number. So a complex number is a number which consists of a real part and an imaginary part. Okay. Just as we know that a whole number, sorry, an integer is a positive or negative whole number. for a complex number, it has two components, the real part and an imaginary part. And the genesis of complex, I think maybe those probably in their second year upward might have encountered complex numbers of some sort. I don't know for the level hundreds, but then let's see what these complex numbers are. Back in the days, sorry, this is too big. Mine is too thick. Okay, so this one is. So back in the days, and when I say back in the days, I'm referring to secondary school. Okay, if we are given this to solve, I'm going to give two questions over here. So what is the root of 4? Okay, and the second one is what is the root of negative 4? So let's solve this first. What is the answer to this question? Anybody can help me with an answer over here. Oh, hello.
Hi.
Come again.
Plus or negative 2.
Okay, so we know that this is plus or minus 2. Okay, and I like this answer very well because this is actually the typical E-math answer. Okay, 4 maths, when you say just 2, I mean, you'll be pardoned, but I think for E-maths, if you don't, or if you're not explicit in your answers, it is not like you'll be wrong, but then you may be penalized. You may not get full mark for just saying 2. All right. And the simple reason is, look, if I have positive 2, and then I have negative 2 over here, and I square positive 2, I get back my 4. And then when I square negative 2, I also get back my 4. Okay, so this is what we know. Then what about if it is root of negative 4? Root of negative 4, the answer cannot be either of positive 2 or negative 2. Because when I square positive 2, I don't get back negative 4. And I square, or if I square negative 2, I don't get back negative 4. So usually when you type this in the calculator, sometimes the answer is not what you want. Okay, of course, there's a setting you need to configure in order to get the complex computation. So this is what is going to lead to a complex number. Now, based on the mathematics that we know, okay, we can expand what we have over here. So for instance, I can have this written as 4 times negative 1. So 4 times negative 1 is 2, okay? And then I can rewrite this as, now we are getting 4 or the root 4, okay? Multiplied by the root negative 1. Now, at least this part is something that we can solve. So we know that this is plus or minus 2. So let's say this is 2. But then the big question is, what is this? What we have over here is what is resulting in the imaginary part of a complex number, because this is a real number. And then the root negative 1 in terms of complex numbers is referred to as I. So over here, this one will result in an I. And then because we are multiplying it, the final answer is going to be 2I. All right. Now let me also make this point that, look, if you work out this, and especially when I remember back in the days when we were doing some circuit analysis, superposition, and all those things, okay, we came to a point where we're using complex numbers to solve things. And the problem is electricity is using I, okay, for current, okay. So there was a conflict of, how do you call it, symbols or, let's say, variables. So when you read a lot of the electrical books, okay, they, instead of I, they use J. So you're going to see 2J instead of 2I. So whether it is 2I or 2J, if they are talking about complex numbers, it's practically dealing with the same thing. So over here, we get the point. So let's look at exactly what this one will look like. Because like I said, when we deal with some of the computations that we are going to do, okay, and fortunately, we are not going to do them by hand, but eventually some are going to result in complex numbers. And since Python is um, built to handle complex numbers, we don't have to worry about that. So let's say I have a variable x, and x is going to be equal to, let's say, 2 plus 4j, okay? When I do x is equal to 2 plus 4j, this is a complex number. And then the 2, as we see over here, is the real part of the number. And then the 4j becomes the imaginary part of the number. So once again, let's try and do the checks over here. So if I'm to print x over here, and I'm to print the data type of x, when I run this, we clearly see that, yes, indeed, we are getting x over, which is 2 plus 4j. And then we are seeing that this is a complex number. Now, look at the thing I have over here, especially with the imaginary part. If I do 4i, I'm running into problems, okay? Because inherently, Python has adopted using J, so we don't have to switch between I and J. We just have to use J. So anytime we see a number with some J around, you shouldn't be scared. It is basically a complex number because it was trying to find the root of a negative value. Okay, all right. Now, the problem here is, look, if I bring a space between whatever thing I have over here, like I can't separate, how do you call it? The imaginary composition of the imaginary part, okay? So if there's a separation, there's a problem. So I need to put it together. Now, in terms of algebra, okay, the way we write things, if it is, let's say, 2 plus, let's say, 1j or 1i, I can simply do 2 plus, let's say, j, because in algebra, you don't entertain writing 1, okay? All right. However, over here, we cannot do that. So if it is 2 plus 1j or 1i, we cannot do something like this. So we get to see the prompt over here that, well, we are running into problems. So we definitely explicitly we need to type in this over here to represent that, look, this is indeed the imaginary part of the complex number. Now, having said this, okay, let's say we have the 2 plus 4j, which you know this is a complex number. And let's say we have y, and then y is maybe another complex number. Let's say 3 minus 2j, okay? And the way complex numbers work, and I'm only doing this maybe for those who haven't done this kind of mathematics before. Their addition and subtraction is nothing difficult, okay? A lot of it actually looks like the way you work with sets, okay? So back in secondary school, those, for instance, if you are dividing sets, you need to do some rationalization and all those stuff. It is practically the same thing over here, in the sense that if you are adding, for instance, x plus y, we are adding two complex numbers. All that we do is we exclusively add the real parts or deal with the real parts, and then we deal with the imaginary parts side by side. So over here, because we are adding 2 plus 3, that's the real part, we are going to get 5. And then it is going to be plus 4j plus minus 2j, and the negative is going to take precedence. So we are going to end up with we are going to end up with it subtracting. So we are going to end up with plus 2j. Okay. So this is going to be the results from this operation over here. So when I save this and then run this, you definitely see that 5 plus 2j. So it is not rocket science. Maybe you haven't seen it before, but like I said, thankfully, even if we encounter complex numbers in any way, there's a way we are going to go about that solution, which we are not going to hard code everything ourselves. So don't be too scared about what you see over here. All right. So now that we have an understanding of what complex numbers are, let's look at the last, but not the least, the type of data that we can also deal with. And this is what we refer to as Boolean, okay? There's a whole history on this, but then a Boolean data type represents data that can exist only in two forms. Can exist only in two forms, okay? So a typical example, are you a student of the university? It is either yes or no. There's no in between. Have you registered? It is either yes or no. There's no in between. Did you um, 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 the next example is something that students have always been finding a middle ground. Did you come to class? Were you present? They usually find a middle ground. But the truth about the matter is it is either yes or no. Okay. So for Boolean data types, and I believe those of you in the upper years, you've done some Boolean algebra and stuff like that, which we're also going to draw inspiration from for other lessons. So for instance, on or off, okay, or high or low. Now, in case or in terms of Python programming, we use true or false to represent Boolean data. So the question is, or maybe the data is maybe is registered. Have you registered for the false? The answer can either be true or false. Now, let's pay attention over here. You could see that when we dealt with the reserved keywords, which we cannot use for our variable names, I made mention of the fact that a variable, I mean, a word like true, okay, is something we cannot use for variable names. And the explanation I gave then, which is still valid now, is that look, Python has reserved some of the possible things that you can declare as your variable names. And it is saying that look, don't use these things as your variable names because I have some specific use cases for them. And with a specific example of Boolean data, it says that look, because I know that there's some data type that can only represent two forms, okay, of expressions. Please don't use true or false for your variable names because anytime I see true, I'm looking at it from a Boolean perspective. And that's what we see over here. So over here, if I'm to do a printing of the variable is registered and proceed to check the data type as well of that variable. When I run this, indeed, I see that yes, the content of that variable is true. And then the data type, as you see over here, is a Boolean data type, as we are seeing bool over here. In that same way, if I'm to say false, we are seeing that yes, the data or the content of that data is false, and then the representation in terms of data type is Boolean. If I do small letter f over here, clearly we have a problem because of the case sensitivity nature of Python. So this is not a valid way of declaring a Boolean data type. All right. Now that we have some understanding of these various data, there's something I want us to pay attention to. And we are going back to the concept of floats or decimal fractions, okay? Because decimal fractions are also going to lead us to something later that we are going to deal with a lot, okay? So let's say I have x and this is 0.1. We know this is some float because it is a fractional value, okay? It is not a whole number. So if I run this, sorry, I've not printed it out. So let me do a printing of the variable x. If I run this, I see 0.1. If I do 0.01, it works over here for me. If I do 0.001, this one will work. If I do 0.001, this one will work. But then if I do 0.0001, then look, we are going into some realms where it is uncomfortable to be writing a lot of the zeros. So back in the days, or even now, okay, what we use is we normally would want to represent these kind of things in the scientific notation, okay, or the standard notation. So standard notation, where we can say, okay, this one, the decimal point is going to move to the right. So we can do 1, 2, 3, 4, 5. So you can say 1.0 or 1 times 10 to the power negative 5. So that's basically what we do, okay? And the way Python does it for us is what we are going to see over here. So we are seeing that 1e minus 0.5. So it is basically 1 exponent 0.5 over here. So the decimal point has moved in that direction. These are the kind of numbers that we are going to see very often, especially with the weights, because they are random numbers, okay, and it could be anything between any value, okay. So we are going to see a lot of these numbers. So anytime we see something like 1e negative 5, is basically telling us that it's 1 times 10 to the power negative 5. All right. Now that we know that, okay, this is the case, at least when I run it, it is looking like this, okay. But then if I'm to check the data type, it still hasn't changed the fact that it is a float or it is a fractional value, even though it is looking like this. So when I run it this way, it is still telling me that this is a float, okay. I could have reversed it by also doing it like this. 1, then I do e, then minus 0.5. This one is also valid, as I have over here. This one is also valid. So when I run it this way, I get to see that, yes, it is still a float. It is not a string because it's not declared in a double quotation mark. And it is not a whole number. But look, when I do this over here, okay, and then I run it, we get to see that it now reverses it because the decimal point is not like too wild for it to shorten things for me. So when you see something like this, it is a float, but it has been written in the standard or the scientific notation. That is also something we need to pay attention to when we are dealing with it, because we are going to come across this over and over again. All right. We are done with this chapter. Let me know if there are any questions before we move on to the next one. Okay, so now let's move on to the next one. And this is going to be very short, okay? So over here, we are going to look at the input function. We've been dealing with the print function most of the time, and that print function is helping us output data onto the screen, okay? Now I want to deal with another type of function that is going to help us input data, and the name is suggestive of what it does, okay? So it is the input function. It is a function that helps us input data into the system. So instead of saying maybe X or maybe name is equal to Kwame, and then if I print out name, indeed I see Kwame over here. Okay. This declaration I have over here on line 2 is very static. It's very static in the sense that at the time I declare the variable, I've already put value over there. Okay. And sometimes we don't want things appearing this way. So we want to use the input function. So I'm going to use the input function. And this input function will tell me that, okay, yes, I want to input something, but I need to kind of give a prompt. Okay, so the prompt is maybe enter your name. Now, this enter your name is going to be printed on the screen. And I'll be given the option to type something. Now, whatever thing I type will now be sent into the container name. And then it will be printed out for me over here. So this one will become a little bit more dynamic. All right. So now let me run this. And indeed, we get to see enter your name showing up over here. So in the terminal, I can type, let's say, my name or my other name is Bruni. So the moment I press enter, that input I typed will be sent into the variable name. And then on line 3, it is saying that, okay, this is what you wanted me to print. And that's exactly what you see over here. All right. Now let's see other things, because some of the things you are going to learn is going to influence the things we have over here. And that's something we'll come back to. But we are going to see a lot of the input function being used over and over again. All right. So let me just comment this one out and then come back to what we have over here. Now, this side is a little bit theoretical, but then I'll try as much as I can to use some few examples to explain a few things. So over here, we want to look at some characteristics, okay, of the Python programming language. Now, if you are coming from another programming language, you realize that, look, there are some things we do in other languages we are not forced to do them over here. Okay, Python is a little bit flexible. For instance, we saw an instance where we could even change the variables and stuff like that. Okay, all right. One of the first characteristics I want to talk about is the fact that some computer programming languages are dynamic, others are static. Okay, our emphasis is on Python, so we are going to be a little bit biased on it. Now, Python is dynamic, and we saw an example earlier on where we had the variable age set to 12, and then the same variable age was later changed, or the value was later changed to 90. And this is one of the dynamism in there. If I'm to come in here and say the variable age itself has now changed to 120 this way, now a few things are happening over here. On line 5, it was just a change. I mean, this was the initial declaration of the variable age and assigning the value 12 to it. The 12 I have over here, based on our knowledge of data type, it is an integer because this is a whole number. In the case of line 6, due to the dynamic nature of Python, I've been able to overwrite that data into another data. This time around, I maintained the fact that both data change are all integers. Now, in the case of line 7, something drastic has happened. One, I've changed the data and I've also changed the data type. And it is possible because if I'm to come back here and do a printing of, for instance, small letter h as I have them over here, when I run this, indeed, I get to see 120 over here. And if I'm tempted to even check the data type of small letter h as I currently have it over here, run this, I'm getting to see that, look, it is a string. And the change has occurred because of the dynamic nature of things, okay? Other programming languages like maybe C++, when you are declaring variables, you declare variables alongside their data type. So for instance, in C++, the change we see over here is going to work because they are the same data type, but then changing from one data type to another data type is not going to be possible. All right. Now, the next thing we have over here is what we have as interpreted languages and then compiled languages. All right. So let me just show you this. Python is an interpreted language. And what that means is, look, that is making it quite unique, okay? So let me explain that using an example. We saw an instance where we have, let's say, name. And name is going to be equal to, let's use the input function. And then over here, enter your name. Enter your name, okay? Enter your name is going to show, okay? And then let's, for instance, do a printing of whatever thing we have over here, name, okay? Or let's say, yes, enter your name, and then let's do something like age. And then let's use the input function, and then the prompt, enter your age, also showing up over here. And then we are printing name over here, and let's say we are printing age as well. But to play the devil's advocate, let's also try printing, let's say, school. Now, clearly, you can see that we haven't declared any variable school over here. This is the beginning of the code. Everything over here is a comment, okay? So we are even getting the prompt that, look, there's a potential problem over here. And that's simply because we are trying to print out something we have not even declared in the first place. But let's see what happens when we run this code. When I run this code, everything works. Because as far as Python is concerned, it is an interpreted language. So what that basically means is, look, it is going to run line by line until it gets to the problem. So on line 5, there's no problem. So it runs. So enter your name. Okay, I type in Ken over here. I press enter. It goes to the next line, which is line 6. Enter your age. I type in my football age over here, 12. It goes on and on and on to the point where it says that, look, there's a name error. And we clearly see that that variable is not defined. Okay, the variable school is not defined. But then if you are to look at the execution of this code, you could see that, look, after entering my name, based on the prompts I have over here on line 5, and also the prompt I have over here on line 6, it went further to print the name I entered, and also because it was just following through with the instructions, okay. And on line 8, it also printed out the how do you call it, the age over here. It is only when it goes to line 9 that I realized that look, there's a problem, and for that reason, there's a name error. The variable name is not defined. This is one of the characteristics of Python programming. Now, because it is an interpreted language, the execution of the code is done at runtime. Okay, so it is going to be executed when it is time for it to run. That's maybe a simple way to understand it. In the case of compiled languages, it will rather wait and check for everything to be correct before the code even starts running. So a typical example, I don't know if, let me quickly do this, maybe in the case of C++, so that if not just for Python programming, maybe those of you, at least for those in the level 100 and the computer engineering student, you tend to appreciate this part very well, because whereas Python will allow certain things to happen because of its inherent behavior, C++ wouldn't allow that to happen. So let me just open this up and then see how things on, this will go. So let me just clear a few things over here. I was, okay. All right, so let me clear this. All right, the way we write code in C++ is a little bit different. So kindly bear with me. This is not the time I'm going to spend a lot of time to explain a few things. So over here, I want to declare a variable string, okay? And I just want to replicate what we just saw in the case of the code we have over here. So I have name, and then let me say, okay, so I have name, okay? And then I have int age, and then let me also, yes, so the name and age is what I was dealing with, okay? So let me do C out, and then I'll say enter your name. So enter your name, and then let me do a cin to accept this into the variable name. This is a little bit different from Python, so don't just, forget about this in the first place, but then I just want to prove a point over here, and then enter your age, and then cin age. Then what I did, okay, in terms of the logic, I did C out the name, okay, and I also did, so let me end line over here so that they are printed on different lines. So let me do end L over here, and then let me also do C out, and then age, and end line over here. And what I ended up doing was to do a printing of school, something I've not declared in the first place. So this is where the problem was coming from. Now, over here, this is how we do commenting. So I've commented this line, so everything is going to work at least up to this point. So when I run this, piece of code, this is the terminal I have over here. Okay, so over here it says enter your name. So I enter Ken over here. It is saved in the variable name that I declared. Okay, and then age I put in 12 over here. It is also saved. So I have Ken and 12 just as we saw earlier on. But then what I'm trying to do now next is if I bring in on CL school, the moment I run this, because there's an error in the code, it does not even execute in the first place. However, unlike what we are experiencing here, in the case of Python, it went on with its execution until it got to the point where there was problem. Okay, so C++ will basically compile everything, check out for everything to make sure that everything is right before it runs. And that's why it is considered as a very good language, because it would definitely make sure that everything is accurate or properly written. All right. Those are some of the restrictions you have when you are dealing with C++, but in the case of Python, there's a little bit of lag. All right. Now, the last point I have over here is a comparison between high level and low level languages. And basically, this is something we are experiencing because look, Python is a very high level language. High level in the sense that the example we cited earlier on with Glenn was that look, if I want to communicate in, for instance, Ga, okay, and the whole class doesn't understand Ga, I need some kind of an interpreter to do the translation for me or the interpretation for me. And that's exactly what we are doing over here because with Python, most of the things we are typing over here actually looks like English language. Okay, it is not rocket science to use our own intuition to know, oh, input, that means you are inputting something. Okay, print, that means you are printing something. We have some variables over here. Everything we are writing is in a high level language, and then behind the scene, Python will just pick it up and then convert it into zeros and ones for the CPU to understand. In the case of low level languages, which we don't even want to go there, things are a little bit different. Okay, you need to pick things from a very low level in terms of very close to zeros and ones before you can write your code. So these characteristics of Python, there are quite a number of them, but then these are the main ones that will help us appreciate some of the things we are going to do later on because of these inherent characteristics, there are some things we can do, and then there are some things we cannot do. All right. So with that out of the way, let's go or move on to the next chapter. And this chapter we have over here is what we call concatenation. It's a very short one, concatenation. So the big question to the big grammar we are hearing over here is concatenation. Okay, so what exactly is concatenation? Well, this simply means we are joining two or more strange values together. The emphasis is joining two or more strange values. So if I have something like first name is equal to maybe Kwame, and then last name is going to be equal to Nkrumah, then I can have something like full name. And we know that a full name is a concatenation or a joining of all your names. Okay, if there's a middle name, that will also come. So I can say first name, and the way we concatenate is we use the plus symbol over here. So first name plus last name as we have over here. Now, if I'm to do a printing of the full name, if I'm to do a printing of the full name as I have over here, when I run this, I get to see Kwame Nkrumah show up over here. Yes, there's a concatenation, okay? Things have been joined together. Perhaps maybe it is not how we want things to look. We want to have a separation between the Kwame and then the Nkrumah. But look, the logic we've given this is just join this for me because we are concatenating. If we want a space, we need to specify. So I can bring in a space over here. And what I've done is, what I have on line 5 is now not just concatenating two strange values, but then I'm concatenating three strange values. The first strange value I have is the first name. The second strange value I have is the empty strange you see over here. And the third or the last strange value I have is the last name. So over here is a concatenation of three strange values. So now when I run this, we get to see Kwame Nkrumah properly formatted over here with the space as we have specified using this empty string over here. All right. So now that we know concatenation, look, we can have a situation where we are doing a lot of classes, okay? So a lot of classes is going to, it's not going to be a very good use of our time, okay? So what we can do is we can use what we call formatted strings, okay? And formatted strings are going to help us avoid a lot of the classes. So let's say I want to print full name, okay? So full name can still be first name plus last name. But this one is going to result in what we saw earlier on where they are joined together. We want a situation where we can have spaces and stuff like that. So in using formatted string, the key word is, look, it is a string. So either double or single quotation mark. And then we prefix it with an F. So the F is also attached to it. We cannot leave a space because once we leave a space, then we get to see this problem. Now, this F can either be lowercase or uppercase. Okay, so we can do F this way. And then we bring in what I call placeholders. Okay, so the placeholders are going to be this curly braces. So I'm going to put in first name and then another curly braces, and then I'm going to say last name. So with this done, I don't necessarily need to specify a plus and another space and a plus. Once I have this in the formatted string format, I can practically do it this way. So now when I run this, everything is looking good. So I can even put up things over here. Okay, so let's say this man, okay, then first name will be picked up, second name will be picked up, okay, was the first prime minister of then was Gold Coast. No, Ghana. So instead of using a lot of classes over here, we are using formatted string and we are using these placeholders to pick up the values from the variables that we have saved over here. And it is making our work very simple. Later on, this is not a major thing, but you are going to use formatted string to format some of the things we'll be getting, some of the output we'll be getting. And it is going to help us output things in a very nice and better way. All right. Now, what I intend to do is we are going to defer this for God willing next week. Okay. I want us to cover, due to the time left, I want us to cover arithmetic operations, and then we'll come back to strings hopefully next week Wednesday to proceed on the other things that we have over here. So now let's look at arithmetic operations. Now, when we talk about arithmetic operations, it's nothing different from what you already know. Okay. So most of the things we are going to learn now, look, if I give you a pen and a paper to do the calculations, you can do it by hand. We are basically learning how we implement those calculations through computer programming and Python for that matter. So with arithmetic operations, we are basically going to learn how we do addition, subtraction, multiplication. And with Python, there are basically two types of divisions. So we have one that we use the single slash, and then another one we use the double slash. So we have what we call the normal division and then the integer or the floor division. And then we use this percentage sign when we want to do modulus operations. Okay, so we want to find the remainder after a division. And then we use the double star when we want to do power operations. So if I want to do 2 to the power 3, I'm going to type 2 star star 3. And we are going to see all that very soon. So let's start with addition. So remember, and emphasis on this, okay? If I have, for instance, a variable called first number. So first number is equal to 12, okay? And then second number is equal to 10. These are integer values. These are integer values. And for that reason, they are declared as they are supposed to be. If I'm to do a printing of, for instance, first number plus second number, it is going to be the normal 4 plus 10 that we know. And this one, we definitely know that the answer is going to be 22. So we are saying that we use this plus for the arithmetic addition operation. However, if for some reason this was a string and this was a string, then it is not going to be an addition operation, but then it is going to be what we just learned, concatenation. Because for strings, look, I cannot say Ama plus Kujo. What is the answer? It is not going to work. Okay, it is only 2 plus 3, or their ages that I can add together. So if it is string, then we are basically concatenation. If it is raw values, then we are adding. So over here, because we are concatenating, let me put this in the comment. It is going to be 12 and then it will join up with 10 this way because they are strange values. Just as we had farm and comma, just join it up together. So because the declarations have now changed and the fact that they are now strange values, when I run this, we see exactly what we see over here because they are strange values. They are not adding, but then they are concatenating. All right. Now, this will also lead us to something because look, if I'm not going to do an explicit um, data assignment this way, okay, and maybe I'm using the input function. So I want it to be a little bit dynamic. So I'm going to say, oh, enter first number. Okay, and then this one too, I want to say, oh, enter second number. So I'm using the input function to say enter second number. So enter second number. And then I want to pick up first number and then sum it up with second number. But then let me also make it a little bit dynamic over here. So let me declare a variable called result. And result is basically going to be first number plus second number. Look, you could clearly see that.
Ken, check your number 5, line 5. The
Line
second
5.
number, you have it, the column. Second
Oh,
number,
okay.
input second number, column.
Okay, all right, thank you, sir. Now, what we have over here, okay, trust me, for those of you who are very new to Python, okay, you look at this and then you ask yourself, is this really the coding we are talking about? Because everything over here looks like English. And it is so because, first of all, we are applying some of the rules we spoke about earlier on. We are using descriptive names and stuff like that. So instead of saying X is equal to this, Y is equal to this, somebody may get confused, especially for beginners. But anybody who sees this for the first time knows that, look, even though I don't understand the programming thing very well, but look, I'm seeing first number, seeing second number, at least I understand English, okay? And I'm seeing some input to be, okay, maybe some input to be something will happen somewhere. And then I'm seeing results. And that result is going to be equal to first number plus second number. It becomes easy on the eye. And that's how I want you to, that's a culture I want you to cultivate in terms of writing code. Do things that will make life easy for yourself. Don't complicate things. All right. So now that we have this on line 7, we want to output results over here because we are now doing the calculation out there. So let's run this and see. So I'll run this. So first number, I'll put in 12 over here. So when I press enter, the value 12 has been sent into the variable first number. And then it is asking me line 5 to enter second number. So second number, I'll put in 10 over here. When I press enter, that value will be sent into the variable second number. Then instantly, line 6 will kick in and a new variable will be declared. And that variable will now be, okay, add first number to second number and then put it over here for me. And then line 7 will be saying, okay, output whatever computation you did. Now, when I run this, I get to see 12, 10. Well, this is not the exact arithmetic operation we wanted. However, that's why I needed to bring this up. This is doing a concatenation. And it is doing a concatenation because of the input function that we are using over here. So now look at this. The inherent behavior by default, this input function will change everything. Whether you typed it in a double or single quotation mark, it is going to accept it as a string. So the 12 we entered over here was accepted as a string. This we entered over here was accepted as a string. So it is doing a concatenation on line 6. However, if this is not what we want, but we really want to make sure that the numbers are indeed integers, then we are going to be explicit over here. Now, what we do is what we call typecasting. We want to change the data type. We want to enforce a particular data type to be what it is. So what we do is we wrap everything up over here into int. So yes, it is the input function that's taking everything, but before it is sent into the variable first number, it is converted into an integer for us. And we do same over here as well. And then everything looks cool. So indeed, before it gets to first number, yes, the input function by default it is a string, but then before it gets to the variable, that container, it is converted into an int. And then same is done for what we have on line 5. And then on line 6, we add both. So now let's run this code one more time. So over here, using same examples, I now put in 12 for the first number and then 10 for the second number. But because I've been able to do the typecasting, it is now respecting the fact that, look, I'm overwriting the inherent behavior of the input function and now converting everything into an integer. So for that matter, everything becomes an integer over here. So this now does not become a concatenation operation, but an arithmetic addition operation on two integer values. All right. Now we could have done that. We could have left it to be, for instance, let me clear this back, okay? So what we have over here is I've cleared the typecasting, okay? I'm still accepting it as strange values. And then when it gets to line 6, I can do the typecasting on the values over here themselves. So over here, before the addition even occurs, the typecasting is also done over here. So I can do it at the point of declaration, okay, or at the point of the mathematical computation. All right, so when I run this, now same logic, at this material point, 12 is going to be accepted into the first number container or variable as a string. So it is a string over here. Now 10 is also going to be accepted as a string, but then immediately line 6 kicks in. That conversion is done quickly, and the result is what we see over here as an arithmetic addition operation. Now, somebody may ask, so which one is the right way to go about it? And it is good I'm teaching you both ways, so that in the future, when you see something funny, it will just click that, oh, okay, this is not happening because of the inherent behavior of the input function. It is accepting it as a string. I need to do a typecasting. There's no right or wrong way of doing this. I've seen instances where you are writing code. The moment you do the typecasting, maybe some code beneath somewhere will do certain things. And we are going to come back to that when we are dealing with a lot of the strange. So when we come back to the strange, this hopefully next week we are going to see a lot of the things I'm talking about. Okay, that look, sometimes it is good you wait and then later on you do the typecasting, and other times you can just do it right at the point of declaration and then you are good to go. All right. So let's move on now that we know everything that we want to know. And let me also make the point that, look, as far as typecasting is concerned, you can typecast into what I'll say anything that makes sense. And let me explain. So for instance, if X over here is declared as a string, okay, and I declare a variable Y, and I do a typecast of X and save it back into the variable Y, what I've now done is I've converted this, okay, based on the typecasting over here into, how do you call it, an integer. And for that reason, if I'm to do a printing of Y, and also to do a printing of the data type of Y, let me do that over here. The data type of Y, we get to see that it is now an integer over here, okay? But if I don't do the typecasting, and over here, what I've basically done is, look, it's almost like I have put this value into this X, okay? And I've put the X, which is the container, into maybe a polythene box, which is now Y. Now I want to output the content of Y. Originally, the content of Y will also contain the content of X, okay? Because there's no typecasting over here, when I run this, we are seeing that this is a string. Okay, because there's no typecasting over here, when you run this is a string. However, if I do the typecasting as I've done over here, this will now be converted into an int. This is not the only typecasting we can do. We can typecast this into a float. Remember, a float is a decimal fraction. So over here, if I typecast this into an int, the value is going to be 12, okay? The float equivalent, if I do this typecasting, is going to be 12.0 because the float should have something point something. So that's what is going to happen over here. So when I run this, we get to see that, look, even though I typed in only 12, but because I'm typecasting it into a float, it is supposed to give me a representation of a float, which is giving it to me as 4.0. Technically, unless maybe you want to stretch the argument, but technically, 12 and then 4.0, technically, or maybe in some regard, in some perspective, are the same. Okay, so that's what we see over here. So it is not just only int that we can typecast, we can typecast into other data types. All right, if and only it makes sense, because this one it makes sense. But look, imagine typecasting AMA into floats. The question is, well, does it make sense? Is it going to be AMA 0.0? Even if it's going to be AMA 0.0, okay, in order to make it a float, the AMA, is it the fraction or the whole number? I don't think this one makes sense. So definitely, when we do this, look, it tells you that, look, there's a value here. You cannot convert string into floats, okay? So the moment you see some of these errors, it's just enforcing some of the rules or some of the logic that you probably are missing out. So these ones does not make sense. So this one is not going to work. All right. So let's move on. So if I want to do, for instance, subtraction, okay, and let's say I have x is equal to maybe 10, and then y is equal to maybe 5, okay, or y is equal to 7, and I want to subtract, I can do x minus y.
Cannot be reached at the moment. That later. Sorry. The person
So x minus y will basically be 10 minus 7, okay? And with the subtraction, we use this symbol over here. So when I run this, indeed, we get the appropriate expression over here, okay? If it is maybe y minus x, that's going to be 7 minus 10, and that's going to result in negative 3. So everything is looking good over here. All right. Now let's look at the other operations quickly. Multiplication, we use 1 star, okay? So if it is, okay, I still have my x and y over here. So let me cap this and bring them over here so that we can use them for the example. So if I'm to do a printing of x multiplied by y, that's going to be 10 multiplied by 7. So we expect to see an answer of 70. All right. So with multiplication, emphasis is we use just 1 star. All right. In the case of division, okay, in the case of division, it's a little bit different. So let me also emphasize on this. In the case of division, look, this division we have over here is 1 slash. And then there's another one we call the floor division, which is double slash. Now, this division 1 slash will always result in a float. So look at this. If I'm to do a printing of x divided by z, okay, and let me make z over here. Let me just declare z. So z is going to be equal to 2. So basically, what I'm trying to say is, okay, I want to have 10, which is x, divided by 2, which is z over here. And we know that answer is going to be 5. But because this is always going to result in a float, we get a 5.0. We get a 5.0 over here. Okay. Now, if it is z divided by y, which in this case is going to be 10 divided by 7. It is 10 divided by 7. When I run this, this is going to be the normal fraction that we know. So this one, you see that it has a lot of decimal points showing up over here. Okay, so this one looks good. So this single division will always result in a float, even if the answer is supposed to be a whole number. It is going to be a whole number 0.0. All right. Now, the floor division is always going to result in an integer value, okay? So once again, if I'm to do slash. So first of all, let me do 10 divided by 2. But this time around, I'm using double slash. The first single slash was giving me an answer of 5.0. But this time around, when I do double slash, I'm getting just 5. So this is what we refer to as the integer division or the floor division. The integer division or the floor division. There's no point anything. However, if it is just 1, it is going to be 0.0. All right. Now, there's a danger over here, and especially the way we do mathematics, okay? The danger is, look, if I'm to do 10 divided by 7, which we know 7 is y, okay? So 10 divided by 7. Initially, when we did this one, it gave us 1.42 whatever, okay? But then if I do slash, because its inherent nature is to return or give me an integer. When I run this, it is always going to be an integer for me. And this integer, there's a temptation to think that, okay, maybe it is rounding it up or rounding it down. Because look at this. If it is just the single one, okay, it is 1.42. So rounding it up to the nearest whole number will give me 1 because the most significant number after the decimal point is below 5. So we are getting 1 if ideally we are rounding it up using this, okay? But that's not the case. It is basically just chopping it off because the other example I want to cite over here is, let's assume it is now, let's say 4. So 10 divided by 4, let's see what we get. 10 divided by 4, we are supposed to get 2.5. So if you are to round this up to the nearest whole number, at least it should be 3, okay? However, when I do the floor division or the integer division, it is still giving me 2. The logic, it is basically chopping anything off if it is float and giving you strictly an integer or a whole number. So that is one way of looking at it. Now, somebody may look, why do you even need this? We are going to see one of the important use cases of the floor division much later. So just hold your gun and just pay attention that, okay, there's a floor division that regardless of whatever thing you do, it is going to give you an integer. Whether it is a float or not, the output is going to be an integer. All right. Now let's move on to the power. And for the power, let's be very straightforward over here. And the reason why, because if I want to do, for instance, maybe 2 to the power 3, okay? 2 to the power 3 is basically 2 times 2 times 2, 3 times. So the way we do that is we do 2 star 3 this way. And we know that 2 to the power 3 is going to be 8. So when I run this, we get the 8 over here. Then what about 2 to the power 4? It's going to be 8 times 2, okay? And that one is going to give us 16, okay? So on and so forth. So this is what we use to represent power or exponential operations as far as Python is concerned. Now let's look at modulus. Now for modulus operation, we are basically interested in the remainders, okay? So back in the days, okay, and this is basically comma. So when you say 5 mod 2, the question is, okay, when I divide 5 by 2, what is going to be the remainder? Okay, and over here the answer is going to be 1 because 2 going to 5 2 times, remainder 1. I think you remember this. So this one is going to be 1. Then what about 2 mod 5? Who can give me the answer to this one? What is 2 mod 5? Two mod 5. The answer to 2 mod 5. Hey. Should I mention names? Two mod 5.
0.
Okay. All right. Somebody says 0. All right. Now, the answer to 2 mod 5 is not 0. So, sorry to disappoint you. The answer is 2. And I'm going to show you a simple trick you probably might have forgotten. Okay. Now, the answer is 2. Okay. Then 5 mod 5, the answer is 0. Because over here, 5 will go into 5, 1. Remainder 0. It is the remainder that we are interested in. Now, what is happening over here when you have modulus operations of this kind? Look, the simple trick is if the number behind is bigger than the number in front, the answer is the number in front. Okay. So this one, we can extend this conversation and say, that, okay, if it is 10 mod 11, the answer is 10. If it is, for instance, maybe 100 or maybe 5 mod 300, the answer is 5. This one you don't need to calculate, just have it at the back of your mind. But then let's see how we write this in Python. So over here, in order to bring modulus operation to there, we can say 5 percentage sign 2. Okay, 5 percentage sign 2. We are trying to say 5 mod 2. And we are saying that this is going to return the remainder. Later on, we are going to see some practical implementation of modulus operations with some of the things we'll be doing in machine learning when we get there. So when I run this, we see that the remainder is indeed 1. Okay. Then what about 2 mod 5? This is the second one. And the simple trick I'm saying that, look, if the number we are trying to divide by is bigger than the number in front, the answer is the number in front, is the number in front. And that's simply because, look, if I divide 5 by 2, 5 will go into 2 0 times. Remember 2. 5 cannot go into 2 for it to have a whole number. Is that okay? So it is 0 times remainder 2. So the remainder over here is going to be 2, or the number in front. So that's exactly what we see over here. Then what about 10 mod 11? Because the number in front is smaller, it is going to be the number in front. So 10 mod 11, the answer is going to be 10, as we see over here. Then what about 5 mod 300? So because the number in front is smaller, the answer is going to be the number in front. So we see 5 over here, okay, for 5 mod 300. And then what about 5 mod 5? So 5 mod 5, the answer is going to be 0, okay, because 5 will go into itself 1, remainder 0. So when I run this, the remainder or the answer is 0. Then, okay, so this is the last one. All right. Now, the last point I need to make over here, or maybe, yeah, the last point is that Python follows the BODMAS, or there's an order of precedence. Okay, so when there's a mixture of these arithmetic operators, okay, we are adding, subtracting, there's brackets and all those things. Remember this. So the mathematics we know is not different from the mathematics we have over here. So we need to be very careful. If we are doing the computations and we need to put things in brackets, bear in mind that those things in brackets are going to be executed first based on the order of precedence before the other ones may fall in. Is that okay? So those are the things we need to remember. So for instance, if I have an expression, so let me call this expression, mathematical expression, and that expression is 2 plus 4 minus 7. Okay. If I put this in brackets, that means this minus this will be executed first. So this and this will give me, how do you call it? Minus 3, okay? And then the resulting answer is going to be minus 1 if it adds up over here. Either ways, okay, so let me do it this way. So this is going to be minus 3, is that okay? And then multiplied by 2 is going to be minus 6 at the end of the day. So because we have explicitly given out the brackets, okay, that's what we get for minus 6. However, if I don't bring the brackets, or the bracket is such that it is looking like this, then it's going to be this times this, which is going to give us 8 minus 7, and the answer is going to be 1. Okay, so this we know when we calculate by hand, and those same principles are applying over here. So some of the calculations that we are going to do, we are going to be very careful, because If you don't bring the brackets, or if we put the bracket at a different place, things are going to mess up. All right. Now, let me end up finally with this one, okay? The rounding of numbers. Because look, when we're doing, for instance, when we're doing 10 divided by 3, okay? And we're getting 3.33333. Or let me say divided by, let me say 7 divided by 3 and see what this value will give me. Let me do 8 divided by 3. Very good. I like this number. So 8 divided by 3, we are getting a 2.66, and then some 5 somewhere. All right. However, if I'm to do a double slash, it is basically going to chop everything up over here. It's not even going to round it up. And then I'm going to be left with the integer value, which is 2. And that's exactly what we see over here. All right. So let's say x is equal to 8. And then y is equal to 3. And then when I do x, y over here, we are getting the integer division or the floor division. When I do a single one, we are getting a floating point value. Now, if we want to round things up, maybe you want to round this to the, 2 decimal places or 1 decimal places, then we need to use the round method, okay? We need to use the round method. And it's very simple. Look, the names of some of the things we are doing over here, sometimes you don't even need to, you can even guess it, okay? So if I want to round something, maybe, okay, if I type in the word round, okay, there's one round over here. And what do I want to round? I want to round this expression, okay? But look, if I leave it like this, remember, by default, this expression is going to give me this, okay? So if I round it this way, it is going to give me, or it's going to round it up to the nearest whole number. And the nearest whole number we see over here when we do the rounding is going to be 3. So when I round it, we are getting 3 over here. Okay, this is not the integer division. The integer division will just chop off the rest of the decimal places. Okay, so it just give us the 2 and it will chop everything. But then over here, we are rounding. What about if I want to round to the, let's say 2 decimal places? Then I need to specify the decimal point over here. So I put in 2. So this is going to be the expression, and then whatever decimal point I have over here. So when I run the code, we see that initially it was going to be 2.666, then 5v at the last end. But because we are rounding it to 2 decimal places, it is going to pick the third 6, and then because it is greater than, 5, it is going to carry on as 1 and then add it to the point we have over here. Like I said, these are things we already know. We can do them by hand. We are basically learning how we implement them in Python. Now, the concept of absolute values is what we know. And the fundamental concept of absolute values has to do with distances, okay? So there's nothing like a negative distance, okay? So the distance from, if you have a central point, maybe Cape Coast is the center, is that okay? The distance from, let's say, Cape Coast to Takoradi, if it is 5 kilometers, and the distance from Cape Coast to, let's say, Accra, which is in opposite directions, if it is 5 centimeters or 5 kilometers, we cannot say going to Accra is on the positive side and then Takoradi is on the negative side. And later on, I'm going to explain, because that may not carry a lot of weight in terms of you understanding the things. Later, I'm going to explain why the absolute values are very important when we are looking at distances of that matter. So if I have x is equal to 5, and then if I want to check the absolute value of 5, which is the x I have over here, it is ABS, okay? So if I put the absolute value of x over here, and I run this, I get 5. Let me comment this one out so that it doesn't print anymore. I get 5 over here. And then if x is negative 5, and I run this, so the absolute value of negative 5 is 5. So it nullifies the negativity. And like I said, the concept or the fundamental concept behind this absolute value is distances. And you are going to see an implementation of it when we come to the machine learning and some theoretical concepts later on. I think our time is up, and then we've covered a lot actually today. So if there are any questions, we'll solve or I'll handle them. If there are no questions, I have an assignment I've typed out. I'll quickly share it with you. It combines the things we covered on Wednesday and then today. Okay. Thankfully, we've been able to cover everything I wanted to cover. So I'll just share it with you. Just some simple coding, you practice, and then hopefully next week, Wednesday, when we meet, we can have a discussion on that. So if there are any questions, I'm ready to attend to them.
So please, apart from the strings and the scientific notation, is
Now, I heard the first part of your question. What I heard is apart from the strings and the scientific notation, I didn't hear any other part because maybe the network. If you can type it in the comment section, that'll be fine. But then if you can still speak, I think that'll also be fine.
I said that with the exception of the string data type and then the scientific notation, is there a different data type that can take like all types of alphanumeric characters, like including numbers?
Okay, so now the network was still bad, but then I got most part of your questions. I mean your question, okay. So let me also use this opportunity to say that look, it's because we are being a little bit biased to machine learning stuff, okay. We cannot exhaust the conversation about some of the things we are learning even now. But because we are gravitating towards, or we are building competency towards machine learning, we want everything to be centered around it. That's why we are doing some of the things we are doing, okay? But let me also show you that the point you make is valid, because look, I can do something like x is equal to, and then I do maybe 101111 or maybe something, okay? And I prefix it with a b. Sorry. I prefix it with let me just do this, okay? So let's say okay, now what we have over here, okay, this is 100 million, okay, in terms of the value of this, okay. Now I'm not bringing this up because look, this what we have over here is nothing different from what you know, because when I run this, okay, this is the same 100 million, just with some underscores beneath this, okay. And what basically this is doing is, look, the data type of what you see over here hasn't changed because it is still a whole number. It is still an integer. Is that okay? But then we would want to use this so that maybe when we are doing some accounting programming, okay, people will know that, okay, this is like the commas we put in between numbers to show the thousands and the millions. So yes, there could be other ones, okay. However, because of our bias towards, okay, we want to learn and build competency towards a certain aspect of programming that will help us with machine learning. We are not definitely going to cover everything, but then we are going to cover as much as things that we need to actually solve machine learning problems. Please, I hope that answers your question, maybe partially. Hello.
Yeah, please. My question is answered. Thank you.
Okay, all right. Thank you very much. Please, any other question? Okay, so if there are no questions, Prof, please, I'm done for today.
Okay, so we can share the what you want to the assignment that you want them to try their hands on the WhatsApp platform.
All right, then.
I was also thinking if we can have a maybe a small network,
Okay, okay,
maybe three inputs with input numbers, and then with weights, and then maybe we calculate the output. Just write a code for the
okay,
output of each of them. Because we haven't done the conversion type, maybe in terms of the function as if it is 1 and 0. So we
yeah,
can keep that segment, but they can find that. And then next time we'll show them how to do the conversion.
definitely. Sure.
Okay, all right. Okay, so if there are no further, then we would meet. Wednesday is a holiday. What do you people think? Do you want us to meet?
Yes.
To meet her from 4 o'clock.
No, Prof.
All right. Sam said no. So which is which?
I think Sheriff has a reason for saying no.
Yeah.
We have a vote. If it's 1 out of 50 something, then he can watch it. He can watch the video. And of course, if majority have, so maybe you can share your views. If majority have the view that we should drop it, then we meet. Our last meeting will be on Friday. And then, because I know you'll be coming to school. Then when you come to school, then you look at, within the week, you look at your timetable and you let us know whether we should keep to the schedule we are doing, virtual 4 p.m. or 5 p.m. You let us know. Then we can then continue. All right. So on that note, I wish you a good weekend.
Thank you, Prof.